Hey guys, welcome back. We're going to go ahead and finish off the final exam review today. So we're going to be doing part 3, which should take you through problems 7, 8, 9, 7, 8, 9. All right, so let's go ahead and go through that and start off here with what appears to be a confidence interval problem. It says you are an environmental scientist and you are interested in the proportion of trees in a large forest that have become infected with an invasive species of bug. You go observe a random sample of trees and record that 68 out of 600 trees are infested. So, based on your observations, calculate a 95% confidence interval for the proportion of all trees that have been infested. Interpret your confidence interval in the context of the problem. As I've done in previous videos, I'm going to focus on the technology aspect. Again, if you are interested in the by hand calculations and stuff, feel free to check out the answer key where I hand wrote those calculations for you. All right. So for this particular problem, we're estimating a proportion. We're doing a confidence interval for a proportion, so we're going to be doing a one prop z int. All right, so I'm going to use the calculator with a one prop z int here. Again, that had how I knew that is because I was estimating a proportion. I'm doing a confidence interval for a proportion, so that is my clue there. All right, I'm going to go ahead and bring up my calculator, start getting my information in. So we're going to go to stat, over to test, and we'll do a one prop z int. Down here, it's option A. We'll hit enter. And we got 68 successes, right? 68 of the trees were infected, and we sampled 600 of them. And we want our confidence level to be 95%. And there we go. That is our confidence interval. Okay, so we've got confidence interval here, 0.08797 and 0.1387. The other way that we could write that, since we're estimating a proportion, I could use the symbol P and put that into an inequality format. So they call this a trilinear inequality, and then this becomes my left and right bound for that inequality. So I can put my 0.08797 on the left and my 0.1387 on the right. The other way to do it is with the plus or minus format. So we can do a plus minus. We put our point estimate over here. So that is the 68 out of 600, which our calculator calculates for us. It's 0.113 repeating. So I'm going to put 0.1133 repeating plus or minus my margin of error. Now, the quickest way to get the margin of error if you're just using a calculator to do the problem is to take this point 1133 and repeating and subtract away from it your left bound here. So 0.08797. And if I do that, I can get a margin of error here. So I'm going to go ahead and calculate it, 0.11333. I'm going to put a bunch just so that we're nice and precise here. Minus 0.08797. There we go. So we got 0.025. And that's my margin of error. Okay. So that would go here, 0.025. And my point estimate was 0.1133 repeating. Critical values, you would have to do an inverse norm to figure that out. Again, the calculation for that is on the sheet, but I'm not gonna do that here in the video. All right, it's because I want to save time and focus on what we can get from just the calculator. All right, so here we go. Let's go to the next problem. Says, oh, wait a minute, I forgot the most important part. It says interpret your confidence interval in context here. So let me write an interpretation statement for you. We are 95% confident the proportion of all trees infested with bugs is between 0.08797 and 0.1387. So that's a good confidence statement. Remember, the key to confidence statements, make sure you do not say that this is a 95% probability. Also make sure that you indicate somewhere in there that you know that you're talking about a population of some sort and not an individual or a sample for that matter. All right, let's go to the next problem. All right, so it says among environmental scientists, there is concern if the proportion of infestation is higher than 10%. Um, so there's this concern, I guess, that the proportion is higher than 10%. Okay, so is there evidence at a 5% level of significance that the proportion of trees that have become infested is actually higher than 10%? So there's concern about this. Now, they didn't specifically say that it's a claim, but we're going to treat it like it's a claim. So someone out there, if someone out there is concerned about it, someone out there is claiming that it is higher than 10%, right? And this is a proportion. Okay, so we're going to be doing a one prop Z test. One prop Z test, and I'm going to set up my null and alternate hypothesis here. All right, so we're going to be testing proportions. So we'll have P. And remember, equality always goes in the null hypothesis. Do not put it in the alternate hypothesis. We're going to say the null or the assumption is that it's 10%. Let's just say that it's equal to 10%. And I should not be putting a percentage there. We always write our proportions with a decimal. The 0.10. Gosh darn it. There we go. All right, and then the concern or the claim is that it is higher than 0.10. Okay, so there's our null and our alternate, and we're going to be doing this to get all of our pertinent information that we need. So remember that our level of significance here is 0.05. So if our p-value ends up lower than this, then we know that we're rejecting the null hypothesis, which means we'll be supporting the alternate hypothesis. All right. So let's see what we get. Let's go to our calculator. We're going to go to stat, tests. We're going to go to one prop Z test, which is option 5. Let's give it all of the information. So we have proportion for the population. It is assumed that it is 0.1. And we had 68 out of 600. Okay. I was already in there, so that's nice. And we're concerned that it's greater than. We'll calculate. There we go. Okay, so we've got our test statistic at 1.0886. So we'll say Z equals 1.0886, and this is our test stat. This tells us how many standard deviations to the right of what we expected. So we were about 1 standard deviation to the right. That's not horrible, right? That's not actually that far away. In fact, 75% of our data is within 1 standard deviation according to the empirical rule. So it's not looking like we have enough evidence here. Let's see what the p-value is. We'll go to our p-value, and our p-value was the second one right here, so 0.138, and then we compare, right? Compare, we take 0.138, we're going to put our 0.05 over here, that's our level of significance. 0.138 is greater than 0.05, so this means that we fail to reject. It was not rare enough, right? We want to be rare to reject. This is not too rare. All right, so we now have to write our concluding statement here. There is not sufficient evidence to support the claim that the proportion of infested trees is higher than 10%. Right? So there shouldn't be any concern. The environmental scientists should calm down. There's not enough evidence to think that it's higher than 10% here. All right? All right, let's go on to the next one. Again, I'll reiterate the by-hand calculations for the test stat and the p-value are on your answer key. Feel free to check that out if you want to see that. All right, so number 8. We're looking at sampling techniques here. This will pop up on your final. I'm going to ask you some questions about that stuff that we learned at the very beginning of the semester. This is important because I'm hoping one day that you're going to find yourself in a job, a profession, or maybe you're in a higher level degree program where you are going to have to read research. All right, and the basis for almost all research is how do you collect that sample, right? Once you have the sample, you can do all kinds of math things. You can do hypothesis tests and confidence intervals and all that good stuff. But if the way that you collect your sample is flawed, none of it means anything. All right. So knowing what kind of sampling techniques are, good sampling techniques, which ones are bad, it helps you when you read that research to know whether or not you are reading a good research study or a crappy one. All right. So that's why we focus on these sampling techniques here. So let's take a look at these. This first one says you survey the first 8 houses that appear to be home. Okay, so you go into a neighborhood and you're going to sample houses, and you just go to the first 8 that have cars in the driveway because you know they're going to be home. All right, so this would be a convenience sample. All right, not there was no randomness to it or anything like that, so we call this convenience. This is the one that you want to watch out for when you're reading those studies. This is typically not approved by the statistical community because it allows for bias. All right. The second one, it says you obtain a list of each house in your neighborhood. You break down the houses by block and randomly choose one house from each block to survey. So this is stratified. Okay. So we broke the houses into things called strata. And so each block in the neighborhood became a strata, and then we proportionately chose from each of the strata. Okay. Now, this next one says you randomly choose a house to start with, and then you survey every 12th house from then on. This is called a systematic sample. So systematic. All right, it's where you take every fifth, every third, every second, whatever number you happen to randomly choose. So you might roll the dice and say, if a 3 pops up, I'm going to take every third house. If a 4 pops up, I'm going to take every fourth house. So there's still a randomness to it, and it doesn't allow for you to pick the houses that you just want to pick. Okay, so let's take a look at the next one. It says you obtain a list of each house in your neighborhood and choose 8 houses to survey. So you have a list, you assign them numbers, and you choose 8 of those numbers at random to survey. All right, so this would be a simple random sample. Simple random. All right, this last one says you obtain a list of each house in your neighborhood. You break the houses down by block. So it sounds a lot like this other one where we were stratified. You randomly choose 3 blocks and survey each house on the chosen blocks. So this one is what's called a cluster. This is a cluster sample. All right, and the difference between cluster and stratified, they sound very similar. Remember, in stratified, we chose one house from each strata. In a cluster sample, we randomly pick 1 or 2 or 3 of the clusters, and we sample every house in those clusters. Okay, so there's no proportional picking from each one like there was in the stratified. All right, so that's sampling techniques. Again, you might want to go back to chapter 1 and take a look at some of those for some more detailed notes on those and some other examples that we did in class. All right, let's take a look at number 9. It says you have been wondering about your oven again. All right, so whether or not it is actually at the correct temperature. You want to know if it's at the correct temperature. All right, so each time you bake something with the oven set at 400 degrees, you have been keeping track of the temperature. The temperatures for the last 12 times that you turned the oven on to 400, you found that it actually had a mean of 396.67 degrees. So it's pretty close to 400, but it's not exactly 400. So, okay, and a standard deviation of 4.68 degrees. All right, so what we want is we want to estimate what the actual mean temperature is for this oven, right? Because it says construct a confidence interval for the mean temperature of the oven at 90%. So not a problem. Now, notice this is a mean. So this is a little bit different than the last one we did. So this is a mean. So we're going to be doing a t interval or a z interval. And I'm going to go back and see. Let's see. So 400 degrees, temperatures last. So these numbers, the 396.67 and the 4.68, that came from our sample. So we don't know anything about the population standard deviation. So this is going to be a t interval. Okay, so we are estimating a mean. That was our first clue. And we did not know the population standard deviation, right? So this was unknown. That's how I narrowed it down to a t interval. All right, so let's do it. And like I said, I'm going to do this on my calculator, the by hand stuff on the answer key. Let's go. Stat, test, t interval is down here at option 8. And I'm going to choose stats this time because they did not give us the raw data for this one. So our mean temperature from our sample of 12, let's see, is 396. 396.67, and the standard deviation from the sample was 4.68, and our sample size was 12 with a confidence level of 0.9. There we go. All right. Why did I minimize it? There we go. So let's write down our confidence level. We got 394.24. 394.24 and 399. Oops. 0.096. There is our confidence interval. And again, I showed you in the last problem how you can take that and break it into the trilinear inequality, or even put it into the plus or minus format. I'm not going to do that again for this problem just to save time on the video. Go back and check out problem number 7 if you want to see how that's done. But this is good. This is our confidence interval, so we can go ahead and write our concluding statement. So we are 90% confident the mean oven temperature is between 394.24 and 399.096 degrees. All right. That's really all there is to this problem. If you're doing this on your calculator, it can be a really quick problem if you know which interval to pick. So take advantage of your technology on the final exam. I am encouraging you to do so. Do not calculate anything by hand unless it specifically asks you to do so. All right. If you do have a problem where it's like, hey, find the margin of error and interpret the margin of error in the context of the problem, you might want to calculate that by hand just to kind of refresh you on what that context is. All right. So let's go to this next one. All right. So using the same temperature data, is there evidence at the 5% significance level that the mean temperature of the oven is less than 400 degrees? It says choose an appropriate test, write down the null and alternate, the p-value, and the conclusion in context. No problem. So we are doing a test on the mean, right? So this is a test for the mean. And we still don't know this. So this is going to be a t-test. So I'll set up my null and my alternate hypothesis. Null, alternate, and our symbols this time are going to be mu since we're estimating a mean. And when you set the oven to 400 degrees, you're assuming that it's going to go to 400 degrees. So our population assumption is going to be 400. We're concerned that it's less than. We looked at our sample data and it's not coming up to 400. It looks like it's going a little bit less than. So I'm going to get rid of this and I'm going to say less than 400 for my alternate hypothesis. All right, so left tail. It's a left tail test. All right, so we know we're going to need our test stat. We know we're going to need our p-value. We know we're going to do a comparison. Here we go. Let's grab our calculator and let's do this. So you go to stat, go over to the test menu, and t-test is option number 2. And we're going to choose stats again. So our population assumption was that the oven should be at 400 degrees. Our sample was 396.67. And our standard deviation was 4.68. All right, so we got sample size of 12. We're going less than this time for a left tail test, and we're going to calculate. Right, so our test stat is negative 2.46, right, indicating that we were 2.46 standard deviations to the left of what we expected to get. That's significant. Let's see if the p-value was low enough, right? What's the probability of getting that far away? That's what the p-value tells us. Probability of that happening is 0.015 or 0.016 if we round. Okay, so then we compare. I'm going to take that 0.016. We have to know, is that rare enough? And compare it to our significance level, which was 0.05, right? So we are less than, which tells us to reject. So we reject the null hypothesis, and then we write our concluding statement. So there is sufficient evidence to conclude that the mean temperature is less than 400 degrees. Okay. All right, last problem on the final exam review. It says, let's say we knew that the population standard deviation was 4.5 degrees. So they are switching it up on us. There's a new piece of evidence that has entered the game, and it is this. We now know the population standard deviation, and it is 4.5. We are still testing a mean, right? Because it says, well, what test would you run? We're testing a mean, and now we know the population standard deviation, so this will be a z-test. And now they actually want us to go ahead and do the test with this new piece of information. So that means instead of doing a t-test, we would run a z-test. But we still need to set up a null and an alternate hypothesis here. And it'll be the same exact test, right? So if I set the oven at 400, it should still be at 400. I would assume that it goes to that temperature. The concern or the claim is that it is less than 400. We're going to need to test that. We're going to need a p-value. And we're going to have to compare. Okay. So let's go to our calculator and do it again. Okay, so we're going to actually go for z-test this time, and we're going to input our stuff, and it's up. The calculator is anticipating what I am doing. Look at that, it had the 400 in there. I didn't even put that in there. All right, so we've got 4.5. Surprised I didn't know that I was going to put 4.5 in there. 396.67. That's correct. 12. Yep. And then we're going to go less than. Yep. And calculate. All right. So test that. Negative 2.563. Okay, so we were negative 2.563 standard deviations to the left of what we expected to get. The probability of that happening by chance is 0.005, which is pretty rare, by the way. It's about 0.5%. So 0.005 is less than our significance level of 0.05, so we reject the null hypothesis. And we would write our concluding statement yet again. It'll be the same concluding statement that we had in the previous problem. Okay. So that is the test, this time under a z-test. So that's it. All right, guys, that is the end of the final exam review. If you've watched this video and there are still problems on your final exam review that you feel like you need help with, contact me and I'll try and set up an appointment with you sometime before the test on Tuesday, right? Well, you could take the test anytime, but it's due on Tuesday at 11:59 p.m. and then I enter in grades on Wednesday. All right, so good luck, and I hope you all do well on your final exam, and let me know if you need help. All right, guys, have a great summer. See you around.